In this video, we're going to be looking at equations of proportional relationships. We also want to look at the correlation between graphs, equations, and tables. Each one of these can represent proportional relationships, and you can convert from one to the other. So let's look at a problem here. Let's look at an example. Dalton is starting a summer camp for children with hearing impairments. He needs to hire enough counselors to chaperone the children. So if we look at this graph here, we notice that across the bottom, the x-axis is the counselors, the number of counselors, and then the y-axis, or over here to the left side, is the maximum number of children that each counselor could oversee. So this says there is a proportional relationship between the number of counselors he hires, X, and the maximum number of children who can attend the camp. So X is the number of counselors, and then that is dependent, or the Y is dependent upon how many counselors there are. So the Y is the max number of children. So what they're asking is, what is the constant of proportionality? So let's look at a few of the ordered pairs. So I see if I have one counselor right here, I can have up to 3 children. So I have a point of 1, 3 on my graph. Another point is, let's do a different color right here. So if I have 2 counselors, I can have 6 children. So I'm already seeing a pattern here. Let's get one more color. So I see another one right here where I can determine what that is. If I have 3 counselors, I can have 9 children. Now, if I put that in a table, it would look like this. If x is 1, y is 3. If x is 2, y is 6. If x is 3, y is 9. So then what I want to look at is, okay, how many, excuse me, how many children can I have for each counselor? That's basically what that constant of proportionality is. In other words, what number am I multiplying x times to get y every time? So 1 times 3 is 3, so I'm multiplying times 3 here. 2 times 3 is 6 times 3, and 3 times 3 is 9, so times 3 there too. They're asking, what is the constant of proportionality? The constant of proportionality is whatever you're multiplying times to get y, so that would be 3 children per counselor. I also wanted to show you, though, how you would actually write this as an equation, because that's what this is titled. It's titled Equations of Proportional Relationships. So let's talk about that before we move on to another problem. To write an equation for a proportional relationship, you have to find the constant of proportionality, and it has to be a multiplication. Okay, so I couldn't say like divided by 3 here. That wouldn't work. I need the constant of proportionality as a multiplication, as a number that's been multiplied times x every time. Okay, so our equation is always going to look like this, and I think sometimes this is made too complicated. Sometimes teachers make this more complicated than it needs to be. So for a linear equation, for a straight line that goes through the origin, you are going to have y equals something times x, okay? Where this right here is the constant of proportionality. So constant of proportionality goes there. So that's called the coefficient of x, and that number is this right here, is this 3 in this case. So the equation for this graph would be y equals 3x, or 3 times x, because I have to multiply x times 3 to get y. It makes sense. You can also go over to Desmos and type in y equals 3x and see if you get the same line that they have in this problem. All right, let's look at another one. There's a huge sale at a grocery store, so Tyrone stocks up on his favorite breakfast cereal, Frosty Crunchy Bunches. As he puts the cereal boxes on a shelf in his pantry, he wonders if he has enough shelf space. There is a proportional relationship between the number of cereal boxes Tyrone stores on his pantry shelf, x. Okay, so the number of boxes is x, right here on the left, and the amount of shelf space in inches the boxes take up, y. Okay, so for 2 boxes takes up 6 inches. Well, guess what? We're about to have the same constant of proportionality here, but that's okay. So 2 times 3, I'm going to put it right here, equals 6. 4 times 3 equals 12. So we do have a proportional relationship, of course, and every one of these is multiplied times 3 to get y. So our y equals 3 times x again, because every x had to be multiplied times 3 to get the y that went with it. And that's it. Let's look at another one. Sasha is excited because her grandfather in New Orleans is going to teach her how to make pralines. Pralines is candy. It's delicious. There is a proportional relationship between the amount of pecans in cups Sasha's grandfather uses and the number of pralines he can make. Okay, so x is over here on the left, y is on the right. So let's figure out what the constant of proportionality is, and that will help us write our equation down here at the bottom. Okay, so what I asked myself is, what do I do to 3 to get 24? In other words, what do I multiply times to get 24? Well, 3 times 8 is 24. Okay, let's see if the rest of these work. 5 times 8, yes, it is 40. 8 times 8 is 64. And 11 times 8 is 88. So my constant of proportionality is 8. So that means y equals 8x. And again, this is the equation. 8, I have to multiply all the x's times 8 to get the y, and that's all that means. So my equation is y equals 8x. All right, let's look at another one. And I think this is the last one I have, and then I just want to show you the relationship between the tables and the equations and the graphs. Okay, Roxanne is measuring the diameter and the radius of different sized circles. There is a proportional relationship between the radius of the circle in inches and the diameter of the circle in inches. Y. The radius is x. Okay, so down here is the radius, and over here is the diameter. What I want to look for is, I'm just going to kind of follow this blue line until I find a point that I can actually say that's what that point is. Because anywhere else on this blue line except for the 0, 0, I wouldn't have really been able to say, because it would be like a fraction number. Okay, so this purple dot, this purple point that I just marked would be x equals 1 and y equals 2. Okay? So it looks like it's going to be times 2. Let's check another one though. Okay, let's follow it up again, and here's one right here where x equals 2, y equals 4. I'm going to do one more, and I think we can all see what the constant of proportionality is going to be. There's one right there where x equals 3, y equals 6. Okay, so what's my constant of proportionality? It's going to be 2, because x times 2 equals y. 3 times 2, 2 times 2, 1 times 2. So my constant of proportionality is 2, and my equation is going to be y equals 2x. Now, let's look at something. What if those numbers had been switched? Okay, so what if it had been, instead of 3, 6, it was 6, 3, and 4, 2, and 2, 1. If I made a table, my XY table, and I had 6, 3, 4, 2, 2, 1, I might look at this and mistakenly say, oh, it's times 2. The constant proportionality is 2 because 3 times 2 is 6, 2 times 2 is 4, but I would be going backwards in that case. We need to go from left to right, and we need to say 6 times what number equals 3. Well, I know 6 divided by 2 is 3, but I need to think of times. For constant proportionality, it has to be times. So 6 times 1/2 gives me 3. 4 times 1/2 gives me 2, and 2 times 1/2 gives me that 1. So in this case, if those numbers were switched, my equation would be y equals 1/2 times x, or 0.5 times x would be acceptable too. Usually we want to see fractions in higher level math. On this problem for another minute, I am going to get rid of this part because this is not part of that original problem. I just wanted to give you an example of what your constant of proportionality would look like if those numbers were switched. But let's look at the graph. We've got the graph here. What I just wanted to really show you just really quickly before I end this, because I'm at my 10-minute mark, is that you can represent a proportional relationship in several different ways. You can represent it with a graph, which we have here. You can represent it with an equation, which we have right here. With an equation. You can represent it with a set of ordered pairs or data points, which are these right here, the 3, 6, the 2, 4, and so on and so forth. Or you can represent it with a table. And the table would look like this. We could do 0, 0, whatever, 1, 2, 2, 4, and 3, 6. All of these represent the same graph, that same line. They're just different representations. So this is 4 ways that you can represent the same proportional relationship. All right, that'll do it for today. Thank you for watching, and I'll see you next time.